The Nintendo Wii has changed the way video games can be played, but the Wiimote can have uses that go far beyond gaming.
So I'm a cognitive psychologist, and one of our challenges is to understand what goes on in the mind and how is it expressed. Most cognitive processes are hidden, and so we have to find indirect ways of getting to these cognitive processes.
Nick Durant is working towards his PhD at the University of Memphis. In his work in collaboration with Drs. Rick Dale and Danielle McNamara,
we track the XY coordinates.
He is trying to see if there is a correlation between cognitive processes and the body's movement.
I'm interested in deception. So deception is a very interesting cognitive process because not only is it hard to detect, but it's designed to defeat detection. People don't want to be caught lying. So they go to very elaborate ways to disguise that deception. But we're trying to find the very subtle cues that can pick up on when people are lying.
Nick says that theory suggests that cognitive processes such as deception can flow into the movement of the body. For example, in arm movements.
These oscillations of movement.
So for this experiment, Nick and his group use a Wiimote as a type of lie detector.
So they get, have you ever type questions? Have you ever been to the moon? Have you ever been to the grocery store? And they have a yes or no response. And depending on how they respond, in terms of how they move their arm, we can see particular trajectories of movement that map onto when somebody's lying and to when they are not. They're going to respond yes.
The Wiimote tracks the movement of the subject in 3 dimensions every 20 milliseconds as they move towards their answer, either yes or no.
The y-axis is going to be the blue.
The subjects are told to intentionally lie on some of the questions so the researchers can analyze the movement.
When they lie, we see a clear trajectory towards what they want to say to be true. That's the initial thing, and then they correct it to a no. And these very clean trajectories of competition show up, and we analyze these trajectories for lots of different factors and variables. The entropy, meaning the variability, the speed, the amount of bend in the trajectory, all these things are cues that we can look at to detect deception. So it's a very sophisticated polygraph.
Then data of all of the movements are processed using an algorithm that Nick's group has developed to analyze the results.
You build this algorithm, this probabilistic mathematical model that says, now, if I take an unknown case, a person that I don't know whether is telling the truth or lying, and I just feed in to this algorithm these behavioral cues, this motion cues and the linguistic cues. This algorithm can say probabilistically whether or not this person is lying or not.
This method of using a device to ascertain the subject's truthfulness is very different from a standard polygraph, which has been around for about 100 years.
Polygraph is very interesting because it picks up on a different set of behavioral cues, on the physiological cues. So in a polygraph, everybody knows you hook up the sensors that look at heart rate, look at the level of sweat, all these things when you're under a high degree of arousal. And so deception in that theory is that arousal is deception.
The Wiimote, however, is looking for variances in movement that are characteristic of deceptive behavior.
The velocity slows down.
Nick says right now the technique is almost 90% accurate, but the scenarios and questions are very simple.
To California. We're currently just using it to see if we can get a baseline of whether or not we can detect these features, whether they exist or not in liars versus truth tellers. But we hope to take this. There's a huge need for this in national security issues, and law enforcement, in police interrogations. All these are situations where you want to detect a liar.
But as the project progresses, they are hoping to be able to have it as an online application as well.
People speak to the computer and they move their mouse, and we can track all these multi-behavioral cues online simultaneously and give an algorithm that goes, this person is using stereotypical behavior that looks deceptive, like they're being deceptive. And so the ultimate goal is to then implement this and use it for these more applied settings and practices.
For the University of Memphis, I'm Andrew Vandevenner, Junior, Broadcast Journalism major.